All right, I want to talk about another type of pressure gauge called a manometer. So like all pressure gauges, the objective is to measure pressure. So in this case, we're interested in measuring the pressure inside a reservoir. And basically the way that a manometer works is that you tap into the reservoir of interest, and usually you put like a U-shaped tube. There are some variations on the shape, but usually it's a U-shaped tube that's filled with a secondary fluid that's different from what's in your reservoir. I'm showing it here as a liquid, but a lot of times actually the reservoir can be a gas reservoir as well. And basically our objective is to figure out so if I put in a secondary fluid here, if the pressure inside the reservoir is above atmospheric pressure, basically it'll push some of this fluid out and up. And how far up the secondary fluid goes depends basically on what the pressure inside the reservoir is. And so our objective here is to figure out what that relation is. So we can use what we know about fluid statics. So the pressure at B over here is the same as the pressure at A because gravity points in, let's say, the downward direction. So the pressures here are the same. If I go from B to C, the pressure goes up by an amount rho gh. So rho times g is specific weight. So I'll use the symbol gamma for that. So so the pressure at C is just equal to the pressure at B plus gamma times hbc. That's the height. So this is actually rho gh going from B to C. And then I would like to relate C to D. Well, the pressure goes up if I go down from C to the bottom of the U, but then it goes back up by the same amount if I go to D, if D is horizontal with C. And so the pressure at D is the same as the pressure at C. And then the pressure difference between D and E is negative rho gh. Where it's this value of h, HDE. And the value of rho is different because we're in a secondary fluid, so I'm going to call that gamma prime. So the pressure at E is the same as the pressure at D, but minus an amount that's rho g in the secondary fluid, so I'll call that gamma prime, times whatever that height difference is, HDE. And if I put that all together, I'll see that the pressure difference between A and E is given by gamma prime HDE, so this height, minus gamma in the primary fluid times HBC. So in a manometer, basically the thing that that matters here is gamma prime. So the amount that the fluid goes up is basically inversely proportional to what gamma prime is here. So generally you would like to use something with a pretty small value of gamma prime in order to get the biggest the biggest rise in the fluid possible. But and then I just point out that this is actually a gauge pressure, right? So this is basically a measurement of the pressure, the gauge pressure at A, which means the pressure relative to atmospheric pressure, which in this case is PE.